Hello, welcome to backending your application with the cloud using Windows Azure Mobile Services. In this session, we'll take a look at the wide array of functionality that Windows Azure Mobile Services can provide to client applications on a variety of platforms, including Windows 8, Windows Phone 8, iOS, Android, HTML5 JavaScript browser apps, or even custom apps that just consume the RESTful API over HTTP. When you create a Windows Azure Mobile Service, you're actually creating a set of services that are hosted by Microsoft up in our Azure data centers. And along with that, you're going to get an Azure SQL database, and in there are the tables that store the data for your service. But rather than connecting directly to that database, Azure Mobile Services provides a set of data services to perform the create, read, update, and delete operations against those tables, and it exposes those services through a RESTful API that's fully documented and consumable over HTTP. To make sure that it's secure, client applications have to have a known API key to access the RESTful API, but we can further require that users have authenticated using either Microsoft, Facebook, Twitter, or Google authentication services. Now, to create client applications, you could create just apps that directly consumed the REST API over HTTP, but that can get kind of tedious as you deal with authentication and hashing and tokens and headers and all that kind of stuff. So to simplify the life of the developer, Microsoft publishes a whole host of client SDKs and APIs that can be consumed by applications running on platforms like Windows 8, Windows Phone, iOS, Android, or HTML5 JavaScript browser apps. In addition to the data and authentication services, Windows Azure Mobile Services also provides push notification services, server-side script execution, monitoring and logging, and even an integration with third-party services like SendGrid for sending email. So let's take a look at how we consume data services through Windows Azure Mobile Services. Remember, when you create an Azure Mobile Service, you get this service in the cloud that's backed by an Azure SQL database, and it stores the tables. If I had a client app, say like a Windows 8 application, that wanted to insert some data into one of those tables, what it would need to do is create a JSON string that has the property value pairs that we want for the object that we'd like to insert. You would then have to open up an HTTP session and make those REST API calls over that. Now, I mentioned, though, that Azure Mobile Services provides client SDKs that simplify that. So, for example, as a .NET developer on Windows 8 or Phone 8, I could simply create a .NET object instead of a JSON string and use the mobile service client to submit the REST calls over HTTP on my behalf. But regardless of how the REST calls are made, the Azure Mobile Service is going to do the same thing. And that's basically going to be invoking a set of Node.js scripts. Now, there's a script for each type of operation, insert, update, delete, or read, on every table in your Azure Mobile Service. And those scripts are actually accessible, so you can come in and customize them. They're just JavaScript. But if you want to modify how those operations are performed, you can definitely do that. But those scripts then perform the database operations, and if necessary, return data back to the caller. Azure Mobile Services authentication is also something you can opt into. So, for example, as a user launches our application, we can first require that they authenticate using one of the providers like Microsoft, Facebook, Google, or Twitter. And when they do that successfully, we'll basically get this authentication token that we can forward off to Azure Mobile Services and then use for authorization to decide what tables they can insert, update, delete, or read from. And then finally, Azure Mobile Services also supports push notifications. Now, with push notifications, we're typically waiting for some kind of an event to occur. And in Azure Mobile, that's usually some insert, update, delete, or read operation on one of our tables. And remember, we have those Node.js scripts that execute when those operations occur. It could also just be some automatic or even on-demand server-side script execution. But regardless, some server-side script is going to run up in your Azure Mobile Service, and it can then consume the server-side APIs to push notifications out to Windows 8, Windows Phone 8, iOS devices, or Android devices using the appropriate push notification services for those devices. Lastly, if you don't already have an Azure account, you can get a free 90-day trial using the link on the screen. And if you download the slides, there's also links off to the Azure Mobile Services, Live Connect, Windows 8, and Windows Phone developer centers. I'd like to jump into demos here, but I've actually broken this demo down into 4 parts. I'm going to start out just by creating a Windows Azure Mobile Service up in the Azure Management portal. And then I'll turn around with 3 separate demos, one for consuming it with a Windows 8 HTML5.js app, a second one for consuming it with a Windows 8 XAML C# app, and a third one for consuming it from Windows Phone 8 XAML C# app. And I've done it that way so that you can sort of follow the client path of your choosing there. I'll also show you that we're actually consuming the same service from all 3 of those clients, and that might give you some other ideas about creating cross-platform apps that consume a single service on the back end. Now, before I jump into this, I would like to mention that you can download the slides and demos, all the files and everything that you need to recreate this on your own machines by simply going in your browser to windows8appfactor.com and then go to the content link. And as you scroll down through there, you should find a link for backending your application with the cloud, and you can download the slides and demos from there. And in fact, when this video is done, I'll upload and post that there as well. And I've already downloaded those. I've got them extracted into this WAMS, short for Windows Azure Mobile Services, down on my local C drive. And I can see the slides are in there. And in the demos folder, there's 3 subfolders. The before folder's empty, but that's a place where you can create your demo projects, or at least download them to. The after folder contains a completed version of the 3 different client apps that I'll create in the demo. And then the assets folder contains text files with step-by-step instructions that you can follow, even code snippets if need be, to get you through the demos. So in fact, let me open that back up, and I'm going to move that snippets file off to my other screen so I have that handy to me. So to get started, the first thing that I need to do is log into my Azure Management Portal and create the Azure Mobile Service. So I'm going to do that, and I'll flip over to my browser here. And I'm going to go to the management portal at https://manage.windowsazure.com and authenticate. All right, and along the left-hand side, I can see a list of all the different types of services that exist up in Windows Azure. In this case, though, we're interested in mobile services. And I can see that I've got some from other demos and other sites that I have running. I want to make a new one, though. So I'm going to click on New. And then from there, go to Compute, Mobile Service, and Create. And I get this sort of new mobile service dialog presented to me here. Now, you need to come up with a unique host name for the URL for your Azure Mobile Service. And so to do that, I'm going to just use this format of to do. I'll stick my initials in there and maybe today's date, which is, let's see, it's the year 13. It's the month of May. It's the 22nd. And I'm pretty well sure nobody else is going to use that name. And sure enough, I get the green check mark back showing me that that's a valid name. You can call it whatever you want. Just make sure it's a valid host name that's unique. This is also going to make up part of the full URL for the service itself, which will be https:// whatever this host name is, .azure-mobile.net. All right, so that's going to be the URL of that RESTful service endpoint that I'm going to point my client applications to. Remember, my Azure Mobile Service, though, also comes with an Azure SQL database. Now, if you already had an Azure SQL database, you could actually choose to use an existing database. For the demo, though, I'm going to go ahead and create a new one. I also happen to have multiple Azure subscriptions, so I need to pick the one that I want this Azure Mobile Service charged against. I'm going to use this one. And I'm actually out in San Diego, so I'll have it put it in the West US data center for me. This is the Azure Mobile Service location. So now I can go on to the next page, and it's going to ask me about the database. And since I said to create a new one, it's going to go ahead and create a new one that's named after the host name _DB. Again, you can rename it if you want to. That default one's fine with me. And then if you already have an Azure SQL server, you can choose to put it onto an existing server or just make a new one. I'll have it just make a new one here for me. And since I'm making a new Azure SQL instance, I need to create the administrative login credentials for that. And I'll just use SQL admin and a simple password here. There we go. And I'll place it in the same data center as the service. It doesn't have to be, but it makes sense. And on the configure advanced database settings, I'll just do that just so you can see them. I'm not going to change them, though. This just lets you pick the edition, and the edition really just affects the range of sizes that are available. I'm going to leave it at the default of a 1 gigabyte web edition, and I'm not going to change my collation. I'll leave those at the defaults and just say OK. So it's going to chug away here in the background and create this Azure Mobile Service for me. All right. and the service is ready. And that really only took probably 30 seconds or so for that to complete. So let's go ahead and drill into it here and see what's in it. So I'm going to click on the name of the Azure Mobile Service here. And it actually brings me in initially onto what's called the Quick Start page. And you can choose to skip that in the future if you want to. I'll leave it on. You can always get back there, though. It's the little icon of a cloud with a lightning bolt on it. That'll get you back to the Quick Start page. But from the dashboard page, I can get some various monitoring statistics on this. There's also some other useful information. Here's that mobile service URL, which is that host name that we came up with, .azure-mobile.net. And notice it's an HTTPS. I can also see this database link off here, and that'll actually bring me into a Silverlight-based database management tool that I can use to poke around inside the database if I want, whatever. So some basic info there on the dashboard page. The data tab would actually show you any tables that you've created for your Azure Mobile Service. And at this point, it tells me that I don't have any. I could create some here if I wanted to. We'll create one using the tutorial coming up here in just a second, though. So I'm going to hold on that. The scheduler would allow you to create server-side Node.js scripts that you want to have execute. And you could run those either on a schedule or even just on demand. Push notifications is where I would set up the different push notification provider credentials that I need. Same thing with authentication is on the identity tab for hooking up to, say, Microsoft Authentication or Facebook or Google or Twitter. That's over here on the identity tab. The configure page we'll come back to in just a second. So let me skip that for a bit. And I go to scale, and this is where I could actually wire up reserved mode, and that's going to let me do some additional configurations, but at a cost, right, as opposed to free, which is what my initial Azure Mobile Service is. And then if you do go reserved, you can then pick your instance sizes and counts and things like that. You can also modify your SQL database here. And then lastly, there's the logs, and that's where I can get some diagnostic information coming back. Well, let me jump over to configure again. And we saw that we created a new database on a new server, and there's links off to those. But the key thing that I'm interested in right now is this dynamic schema. And notice that that's on by default. And what that means is that when I insert objects into a table, if the objects have properties on them that don't have corresponding columns in the backing table, Azure Mobile Services is going to go ahead and create new columns on the fly to store the values for those mismatched properties. That's really cool. This kind of creates a code-first development model where the developer of the client app decides what they want to store, and the service just sort of morphs to fit the shape of that data. If you're a DBA and that scares the heck out of you, you can come in and turn that option off, and then you'll just have to formally create all your tables first before clients can submit data into them. But I'm going to leave it at on, and on is the default, and we'll see that happen. All right, and at this point, then, we've got a functional Windows Azure Mobile Service, but it doesn't really do anything unless we connect up to it from a client application. So I'm going to jump back over to the quick launch page, and you'll notice that from here, there's some simple tutorials to get you started for Windows Store apps, phone, iOS, Android, or even HTML5 JavaScript apps. And then we'll go through two different flavors of a Windows Store app, as well as a Windows Phone 8 app in the next demos. Great. So now that we've got this Azure Mobile Service created up in the cloud, let's take a look at how we can consume that from a Windows 8 Windows Store client that uses HTML5 JavaScript as its language. So I'll flip back over to the management portal, and again, on that Azure Mobile Service, on that Quick Start page, you'll notice that I can download some tutorial apps here. And so the first thing I want to do is choose my platform, and we're doing Windows Store, so I'm already there. And under Get Started, I can choose to either connect this up to their demo app or follow some instructions for connecting it up to an existing app. And for this demo, I'm just going to use theirs. And so the steps are to get the tools, and that's basically Visual Studio Express. And I've already got that, so I'm good to go there. The SDK itself is actually going to be pulled in through through NuGet. So I don't really need to download and install the SDK. I can just get that through NuGet. But then I need to make sure to create a table. Remember, we were looking at this data tab just a bit ago, and we see that there's currently no tables. That means actually back in that Azure SQL database, there's no tables that Azure Mobile Services knows about that it can keep data in. So back over here on the quick launch page, it's going to give me a way to actually just create one that is going to be called to-do item. The name of your table is important because that's going to be how we map up to it from our client applications. Now, I could just have gone and created that myself, but this little tutorial steps makes one for you with the right name. So I'll just click on that button. And it's actually going back to the Azure SQL database and making a table. And in fact, if I scroll back up here now and look at data, I can see that there is in fact a to-do item table. It's got one index, which is the primary key. There's no records in it. And if I actually browse into the table, I see that there's no records in it. If I go to the columns page, I see there's only a single column called ID. Remember that dynamic schema option I showed you just a minute ago is on. And that means that when we insert new to-do items, like with a title or a completed or whatever, Windows Azure Mobile Services is going to go ahead and create the additional columns on the fly for me. So that's really cool. All right, so let's go back up to the service, back over to my quick launch page. And then the last step here is to download their sample application and run it. And I can choose for a Windows Store client to get that either as C# or as JavaScript. And in this one, we were talking about HTML5 JavaScript. So I'll download that sample app. And I'm going to save as. And we'll go into that WAMs demos before folder and save it out there. But just to make sure, I'm going to save this as a JS. So I know it's the JavaScript one. And before I extract this, anytime you download zip files from the internet, Windows doesn't trust them. And if I extract this and try to open it in Visual Studio won't trust it either. And I'll get these warnings. And it's okay, it works and everything's fine. I just don't like the warnings. So before I do that, I'm going to right click on this zip file, come down to Properties. And as long as you trust the source and you trust the zip file, then you can go ahead and unblock it. And you're basically telling Windows, go ahead and trust that thing. Stop bugging me. So I've done that, and then I can right-click on this, and I'll just extract it out to a new folder in the local directory, and there it is. All right, and notice that inside there I get this pre-created Visual Studio solution. And I can just double-click on this file, and it'll open up that solution for me. And inside the solution, I can see that I've got this project, and it's a HTML5 JavaScript project. So the first thing I'll show you is if I right-click on the project and come down to Manage NuGet Packages, I can see that the Windows Azure Mobile Services for WinJS NuGet package has already been installed in this solution that I downloaded, right? So that's already there. If it weren't, that's how you could get the Azure Mobile Service library, though, for your JavaScript app. So that's good. And where that actually manifests itself then is inside this JS folder. Notice that I've got some mobile services files. There's the actual mobile services.js. That's the actual JavaScript library. There's then a minified version of that. And then there's also a version that has the XML documentation that IntelliSense needs to be able to work with it. And then finally, there's a compiled resource file that's down there. So those all came down through that NuGet package. Now, the app itself, remember our table was to-do items. So the sample application is to help you manage to-dos. You can put in a new to-do item, and then when it's complete, you can mark it as complete, and then you can see a list of all the ones that you have. And so all that's going to be shown here on default.html. So first of all, notice that I've got a script reference off to that mobile service.js library. So that's there. And then as I scroll down, there's basically just a few things. First of all, I've got a text input, and that's going to be where I can type in the thing that I need to do for my to-do item. And then there will be a save button called button save that we'll click on to actually do the insert onto the back end. And then if I scroll down a little bit further, I've got a button that I can use to refresh, requery it from the Azure Mobile Service. And then finally down below, I have this list view here, I have this list view here that's got this item template that's basically going to show a checkbox for each to-do item, and then a div that's going to be bound up to showing the text of the to-do item, whatever that happens to be. So that's going to be a property that we show through binding, and then we also have the complete property that'll be bound up to the checked status of the checkbox that's in there. And those are all going to be shown in a list through this winjs.ui.list view through data binding there. All right, so that's what my UI looks like. Where it actually gets implemented then is back in this default.js file. And if we look inside the app.onActivated function, then I can scroll down here and I see a few things. First of all, from that Win.js library, there's this mobile service client instance. And notice that we're connecting it up to that HTTPS URL for our service. Since I downloaded it from my services quick start page, the solution or the project already had the right values for the Windows Azure Mobile Services endpoint, as well as for this management key. And that management key is actually back over here. If I go back up to my mobile service into the dashboard, notice I can see manage keys. And so there's this application key that client applications have to know. And you can copy that and use it, but notice it starts with a OLY, whatever. And if I flip back over to my source code, I can see that same OLY, right? So since I downloaded it from my quick start page, it already had the right values. And so now basically this client instance here is how I'm going to be able to interact with that RESTful API directly from JavaScript. And I don't have to do low-level HTTP REST calls. I can just call methods like, hey, get me a table and point me at the to-do item table. So I can now perform table operations like inserts, updates, and deletes, etc. So that's really cool. So I've got this client variable. I've got a variable called to-do table, which is a reference off to the to-do item table up in Windows Azure. That's awesome. Look at this. I mean, I could come down here and say, hey, a to-do table dot, and from there I can do things like insert and delete. It knows about that, and I can perform those operations directly against that. It's so awesome, right? So those are all server calls that are happening. But I also need an in-memory collection of to-do items that I can use for displaying purposes, and this is what I'm going to bind up to that list view back on the other HTML page we were just looking at. All right, so the way that items get inserted is that, remember that save button gets clicked. So down here's my button save click event. And what we're going to do is new up this JSON object. We'll set the text property to whatever the value is of the text input. And we'll set the complete to false because we assume if you're adding a to-do item, it must not be done yet. So we'll assume it's false or that it's complete as false by default. And then we pass that JSON object off to this insert to-do item function. And so insert to-do item is up here. And that simply uses that to-do table's insert method and sends that object right up. That is so cool. And when that's complete, assuming everything worked, then we'll go ahead and add the item that we just inserted into our local collection. And that's going to be displayed over in the list view. For querying purposes, we had that refresh button. So down here, there's button refresh. And all it does is call this refresh to do items. But also, when the app is activated, it calls refresh to do items. And all refresh to do items does is goes and queries that table using a where clause, only returning ones that are not yet complete. We want to see to-dos, not to-dones, right? So we tell it to read the results from that query. And when that's done, we take the items that were returned, those results, and we turn them into a list. And then we bind that list up to our list view as its items data source. So that's going to cause it to be displayed back up there on the page for us in a list. That's really cool. And then finally, if you come in and check an item, we'll go fire off this update check to do item. Actually, sorry, down here on list items. When it changes, then we'll go grab the to do item from it, mark it as complete, and pass that to do item into update. And then update simply calls against that to do table the update method, passes up the item to update. And when that's done, we remove it from the local collection. And that's because the only update you can really do is to mark an item as complete. And once it's complete, we don't want to see it anymore. So we just remove it from the local collection. And that's it. I mean, that's all the code. So there's really not much to it. So let's go ahead and run this on the local machine. And there actually is a query running in the background. It's going up to that service and saying, show me all the to-do items that exist. And there aren't any. So my list view would be over here, but it's empty right now. And we don't see any data. So let's go ahead and type in something. Let's say demo with HTML5 JS, right? And I'm going to save that. Now remember, this is when the insert happens. So we create a new JSON object. This will be the text of it. And the complete property will be false. Remember, my table didn't have a text column, though, or a complete column. But with dynamic schema, it's going to create them for me. So we'll hit save. Then it requeries, or sorry, it updates the local collection. And through data binding, we see that new item appear. So that insert has already happened. We can actually verify that. If I jump back over to my browser, let's close this up and go back up to that data tab. to-do items now shows one record. And if I navigate into it, I can actually see the to-do item and that it's currently incomplete. That's really cool. And if I look at columns, notice that the text and complete columns got created on the fly because of that dynamic schema. That's really cool, right? All right, so let me return back over here. And we'll add a few items in here. And so I've now demoed with HTML5 JavaScript, so I could mark this as complete. I could turn on the checkbox for it. That fires the update. I can requery if I want, etc., and get my data back. Notice I'm only getting completed items returned back to me. That was that where clause on the to-do table read. And back over here, if I refresh again and look at my data, I should now see that the original one was now true, complete, but that I had this other one that's still incomplete to false. Really cool. All right. Awesome. So that was pretty easy. Let's turn around and do exactly the same thing now, but with a Windows 8 client written using XAML and C#. So I'll navigate back over to the browser, and in my Azure Mobile Service, back to that Quick Start page. This time, I'm going to download the project, but as a C# project. So I'll download that. We'll give it the CS name. And again, I'm going to unblock that before I extract it. Properties, unblock, and OK. And we'll extract it out to a folder here. Now, I've already got this solution open back here from the JS one. I'll go ahead and stop that and close that guy up. And back over here in the C# folder that I just downloaded, I'll open its solution. And just like we saw with our JavaScript version of the client application, the SDK is actually installed through NuGet. So if I right-click on the package and go to Manage NuGet Packages, I'm not seeing them all. And that's probably because I need to do a build. So let me jump back here really quick, and we'll go do a build. In fact, we'll do a rebuild solution here. All right, and let me try that again. Right-click, Manage NuGet Packages. There we go. That's what I was looking for. And notice that the Windows Azure Mobile Services package is installed, but it also has some dependencies on Newtonsoft JSON, the BCL Async, Microsoft.NET HTTP, and in fact, BCL has its own dependency on the build one. So if I look up here, I can see all these other packages are there just because of the dependencies of Windows Azure Mobile Services. So they're all there, and that's how I get the SDK. Now, if you didn't have it, again, you could just go to online, search, for Windows Azure Mobile Services or something like that, and then you'd be able to find the SDK there. I see mine's already installed, so I'm good to go. So I'm going to close that up and take a look at a couple of things here. In the app.xaml, if I look at the code in that file, the app.xaml.cs, up here at the top, you'll notice that I'm declaring a public member called mobile service that's just statically available on the app class. And so this is the mobile service client that wraps up the REST HTTP calls for me. It knows already the proper URL from my service, and that's because I downloaded it from my service's quick start page, as well as the application key. We saw those back in the JavaScript version previously. So that's how my client app is going to have access to this mobile service. Anywhere it needs to, you can just talk to mobile service and write code through there. Back over in mainpage.xaml, then, if I look at the UI, and you can ignore these yellow warnings. These are just from user controls. But basically, there's a text box that I can type my to-do item into. I've got a button that I can click on to save. I've got a button over here that I can click on to requery. And then down below, here's this list view that's going to be bound up. The exact same structure or layout as the JavaScript version, just using XAML controls instead of HTML. Back over in the code behind then, I've got this to-do item object This is something we didn't see in the JavaScript project because it just used JSON. But here we can actually use a .NET object, and we can map it up to the JSON and say, hey, this text property, capital T, maps up to the JSON text, lowercase t, if you want to have, different names. Or in fact, this will even eventually map up to the column in the table called text with a lowercase t. So you can map them up to different names if you want to have nicer, more, sort of formal property names in your .NET code out there. So there's the properties for any given to-do item. And then down inside main page, I've got a mobile service collection. This is going to be the in-memory collection of items that I'm going to bind up to. But then I also have this to-do item table that's going to go to that mobile service and get the table of to-do items. This is very similar to what we did on the JavaScript side. But now basically anywhere I want to work with that table, I can just use this variable, and I can do things like, hey, to-do table, go insert, asynchronously into the table for me. So that's really cool. All right. And then again, very similar to what we had in the JavaScript side, when the button is clicked, button save happens. We go new up a to-do item. It's just this time, instead of it being a JSON string, it's an actual .NET object, and we set the properties on it. And then we simply pass that off to this insert to-do item method. And insert to-do item then simply calls through that mobile service client API, insert async against that table, awaits the result, and then adds the newly added item into the local collection that's going to be bound up to our list view. Refreshing the data, same thing here. We've got this button refresh that we can do, or anytime we navigate to the page, it also calls this refresh to do items. And that's down here in on navigated to, there's a call to it. And if I go look at what refresh to do items does, there we go. It goes and basically down here queries the data where to do item complete is false. So only find ones that are not yet done and return those back to me as a collection into this items collection. And as long as that all works, we set the list view's item source to that collection of items that we retrieved. And then finally down here, when we have a checkbox that gets checked, we'll go retrieve the to-do item from it and send it to the update method. And the update method simply fires off to the server, say, hey, go update that item, marking it as complete, and remove it from the local collection so we don't see completed items. That's it. Again, exact same pattern we saw in the JavaScript app, just written with with XAML and C# in this case. Now, when I run this, it's actually hitting exactly the same service that the JavaScript app was using. And so we see that I already have some to-do items in there from the previous JavaScript client, right? And this time I want to demo with XAML C#. We'll save that up. Even more. Save that up. Right, and there it goes. And I can mark this guy as complete, and we see it gets updated and removed from the collection. And of course, I could jump back over to the Azure Mobile Service and see the data there as well. So if I jump over here to the browser and go up to my data tab, it shouldn't be a surprise here, but inside to do item, I now have those additional rows. Really cool. For my final demo, I'll show you that Windows Azure Mobile Service being consumed from a Windows Phone client, also written with XAML and C#. There's not a native HTML5 JS story on Windows Phone 8, so I won't demo that way. Flipping back over to Azure Mobile Services in the management portal, we'll go back to the quick launch page. And this time for the platform, instead of Windows Store, I'll switch over to Windows Phone 8 and come down to download the sample app. And there's only one choice there. I don't get to choose languages. So I'll download here and save as. This will be my Phone 8. Open that folder and unblock it. And extract. And I'm going to go ahead and close up the existing Visual Studio for the Windows 8 client. And over here, then we'll open up the Phone 8 solution. And this is exactly the same as the Windows Store XAML C# client. I mean, there's literally, one or two differences, and that's about it. But if I right-click on, well, here, let's first go do a build. So I'll do a build, make sure that succeeds. So, all right. Right-click in here, manage NuGet packages. We see the same packages loaded in through NuGet, but there's the client SDK. And just like we saw here inside my app.xaml, I've got this mobile service client pointing off to my URL with the right key. Inside main page.xaml, the layout's a little bit different, but the idea is the same. I've got a text box to enter new items in, a save button, a refresh button, and then down below is, instead of a list view, it's a long list selector, but same idea. I've got a data template bound up that's going to show my data for me. And then finally in the XAML down behind, or sorry, the C# behind the scenes, it's literally the exact same code here. There's my to-do item class. Here I've got my collection of items in memory, as well as a reference off to the to-do table from that mobile service. From that mobile service. There it is, getting the table of to-do item. And then the same methods here for inserting, updating, deleting, refreshing. So let's go ahead and run this in the emulator this time. All right. And again, I can see the incomplete versions from previous demos. I can come in here and type in. Let me actually remove the keyboard so I can type here. I'll do my demo with phone 8, XAML C#. Save that up. I see it appearing there, and we'll demo more. There we go. Mark an item as complete, and there we go. All right. Really, really cool. Hopefully you see from that how easy it is to create a Windows Azure mobile service and then share data with that service across a variety of clients. Now, in those demos, I didn't get into the other functionality, authentication, push notifications, server-side scripts, etc. But there's tutorials for all of those for each of the major platforms. So you can jump back to the Windows Azure Management Portal, follow the links off to the tutorials, and go have fun with Windows Azure Mobile Services.